Alright, so welcome back. This is the JNCIE SP video. So we're going to continue that. Okay, so last video we learned about fast reroute. We did, so we did, we're on to our fourth video now. Okay, so we're going to be trying to set this up and making sure that we can do everything that's required in there. So I'll pull up GNS3. Okay, so okay, so here's the lab. So let's look at the requirements. So right here. So I do have all of the IP addressing for both the physical addresses and the loopback addresses. I do have single area OSPF configured in AS65432. And I do have RSVP deployed. So what I'm doing right now is trying to establish LSPs between the PE routers. But unfortunately, I had encountered issues in the last video, and these are the same issues I've been frequently encountering. I really just don't know how to get around them. But let's just take a look at what the issue is. So you can see I've got my configuration. It's really not going to be that difficult. It's just this here. But if I look at the results, we can see that it is in state down. If I look at the results in more detail, we can see CSPF failed, no route toward that destination. So I'm not sure why, because if I do a show route 192.168.0.4, we do have an OSPF route to that destination. If I do a show TED database, so this is 192.168.0.4. Oh, okay, so this is interesting. So, yeah, perhaps we don't have, yeah, I think the database needs to be different. So let's try setting the, so we'll say Juniper MPLS loose. Yeah. Okay, yeah, so we can make our ERO either loose or strict. So the way we do that is we create a path, and then we include loose or strict. So let's try that. Okay, and I don't think I'm going to need the from statement, so I'll get rid of that. Now, what's the difference between the path statement and the label switch path statement? Oh, you know what? I don't think you can have a label switch path statement without a path statement. Because I think the path statement is what creates the label switch path. And then the label switch path is what you use to add features onto your label switch path. So I think you're always going to need, at the very least, the path statement. So let's do a delete label switch path. Yep. And we'll do an edit path. Okay, and we'll give it a name. So you're always going to need this sort of statement. Address of next system in path. Oh, okay, so, well, I guess we can just give it, well, let's make it go, yeah, let's make it go through the transit router. So we're going to need to figure out the loopback address. Okay, so this will be an IP address in our path, and we're going to make it loose because it's a loopback address. Okay, and then we'll need one more. Okay, so I think things might be a bit different now. Let's take a look at how this changes things. Okay, so now we just don't have any LSPs at all, which makes sense. But we do have a path now. Let's see if we have different output in the TD database. Okay, that looks the same. Alright, so now that we've got a path, let's try making the LSP. Now, one thing that is interesting to notice is we can see we've got path name is the variable, so name of path. So here's our path name. I think that's where I was going wrong. I was using a path name for a path that hadn't been created yet. Okay, so now I can set my to statement, and now that there's a path, it'll know how to get there. This is why there was no route to the destination, because I didn't have that path statement. Or at least if it works, that's the proper explanation for why it works, I believe. Okay, so we do have one now. Let's see why it's down. Okay, so we've got the same problem. We've got no route. Huh, okay. Well, you know what? I'm going to need to take a quick break. I'll be right back. Alright, we got a red circle, so I'm back. We're trying to figure out why this is in state down. Well, I mean, we know why. The reason it's in state down is because there's no route to host. Or not no route to host, but there's no route toward. So let's Google for this. Okay, so that's actually a good idea from Yasmin Lara, is try to disable CSPF and see if it comes up, and if it doesn't, then you've got interfaces that are misconfigured. So let's try that. So I'm kind of worried that it'll just come up, and I'm not sure what the issue will be then. I kind of hope it's an easy issue, like there not being interfaces configured. So let's delete, or let's do, yeah, delete protocols MPLS path. Oops. Okay, and then we'll do edit protocols MPLS. Okay, so we've got CSPF disabled now. Let's see if it comes up. Alright, so we do have the fields filled out now. That wasn't happening before, but it looks like it's still state down. And we still got no route towards destination. So let's try clearing everything. Okay, so it's still down. So that's good news though, because it means that um, I've just got MPLS missing from some of my interfaces. So let's check these three routers to see which interface it might be missing from. And if it looks like it's enabled on all of them, I will, instead of using that interface all configuration, I'll change it to specifically call out the interfaces. Okay, so let's start by verifying that. Yep, so it looks like OSPF is enabled on all, RSVP as well, and MPLS. Okay, let's check the next one. Okay, so OSPF is on all, RSVP, and MPLS. Alright, looks good. Let's check this one. Okay, OSPF, RSVP, MPLS. Perfect. Okay, but it's still not working, so very clearly, there's going to be another issue. So one thing I can try is to, instead of say interface all, I can specifically call out some of the interfaces. Another thing I can do is verify the IP addressing between the routers. I think I'm going to start by doing that. Okay, so we're going to do, okay. Okay, it looks like the middle one I accidentally pinged myself. I want to ping the other side. There we go. Okay, so let's try this one now. Okay, and then this one, of course, is going to work because the other ones worked, but the other ones did work, but I'll still check it. Aha, so, oh, nope, that worked. Okay, so everything worked. Let's try, instead of using those general all statements, let's specifically configure it on the interfaces. So we'll start with OSPF. Okay, so next we'll be doing RSVP. Alright, and then the final protocol will be MPLS. Right, so we've got all three of those protocols with now specific assignments instead of just that interface all statement. There is one that I'm going to add right now. I'm not sure if it has to be there or not, but it is the loopback interface. Okay, so now let's do the same thing for the remaining routers. Okay. Oops, and I will add the loopbacks to all of them. I'm not sure if that's going to be necessary or not. I know it is necessary. Whoops, for OSPF, but I don't know if it's necessary for MPLS and RSVP. All right. Okay, and I forgot the loopback addresses again. Okay, so next step is going to be to verify the LSP. Okay, so it's still down. One thing to remember though is I still have CSPF disabled. But it looks like the error message is still no route towards test. Let's see if that increments up to the 11th time, because maybe it just didn't do the recalculation. Okay, I don't see anything. Let's try to force the recalculation. Okay, so we can see it's back down to 2 times now, but the problem is there is still no route to destination. Okay, so we're going to enable CSPF by deleting the command no CSPF, as you can see here. And hopefully that makes a difference. So same thing. We just plain can't have a route towards that destination for some reason. I don't understand why. It looks like the forum was wrong about well, so it's saying that there's a problem with the physical links. Yeah, and if I'm pointing to a loopback, loose would work, but not strict. I knew that. But I did try not pointing it to a loopback. Let's try that again, because I haven't tried that in a while. So we're going to point it to GE1. Okay, so we're going to point it to .14. Oh my god. Okay, well, I don't know what's going on. I don't understand what's going on. Let's look at the TED database. And maybe there's maybe the other physical loopback would be better. Now I do notice we've got 14-1. So I don't know why there's a -1. Let's take a look at this link a little bit more close. So okay, so the subnet is .12. So we've got .13 and we've got .14. So I would have thought that this would say /-13. So I don't know where this -1 comes from. Okay, but let's try the other one, 34.14 instead of 23.14. Okay, so I believe we actually already used 34. Yep, so we're going to try 23.14. Oh, so we can't use .14. Would have to use .2. Ah, I found it. Now this is interesting because, oh no, I didn't find it. Oh, no, I did find it. I think. No, this is right because it's .23.13 on 000, which we can see goes to 1, and then 000 goes back there. So yep, this is correct. And then here we've got .24.2, and here we've got .24.1. So all of the IP addressing is correct. But we can't use 23.14 because that goes to the transit router. We've got to use 23 or 24.2. Okay, so same problem, no route towards 24.2, even though if we look at the traffic engineering database, we do see that there is a route to, oh, okay. Yep, we do have a route to 24.2 right here. Ah, so here's something really interesting. It looks like our interfaces are in state down. Just our plain old MPLS interfaces. So I think this is where I'll come back to it. I'll give this at least one more video because I just want to figure out how to get these up, of kind of where my gap in knowledge is. So thanks for watching, and I'll see you in the next one where we try to figure out how to get these MPLS interfaces to move to state up.